Hi, I'm JJ Horns. I'm an assistant professor in the Department of Surgery, and I am a big data biostatistician answering questions about public health. Before I joined the Department of Surgery, I was a conservation biologist. One of the aspects that I really enjoyed was working with really large, unstructured data and answering questions that you can really only answer with these really large data sets. And during my PhD in conservation biology, I really fell in love with that type of work. And when I was sort of wrapping up my doctorate, I wanted to still work in that same sphere, but take those methods and address them to questions of healthcare. One of the big impacts I want to have is working with a lot of different people, not just physicians, but also med students, residents, fellows. What I'm really hoping to do is increase that access to people who are interested in doing research. They have these questions that they're really wanting to answer, and they know this can really impact patient care. So what really motivates me is being able to work with these people from all different types of research experiences and help them produce these high quality, advanced analyses that they can then go and make real differences in the lives of their patients. One of the big ways that big data science is evolving is in recognizing its own weaknesses. Something we like to say in big data science is if you put garbage into an analysis, you get garbage out. And there are a lot of inherent biases in these big data sets that we work with. If you are not accounting for those and you're not understanding them, you can produce results that may impact healthcare, but it may cause increased disparities in healthcare because it may help certain populations that are well represented in big data and harm other populations that are not. So one of the ways I really see this field evolving is in recognizing those disparities and working with ways to overcome them. There are initiatives to create better representation of all different types of groups in big data so that these healthcare analyses are more accurate. Another way I really see this evolving is in increasing who is able to do research, making sure that anyone who really has an interest in doing research has a place where they can work with our group and they can do this research that they're really interested in and they feel like can make a real impact. Funding research is incredibly important because that is how we find gaps in patient care, and it's how we figure out how we can address those gaps and improve the lives of patients. A really good example of this that we did recently was looking at survivorship after cancer in our patients here in Utah, comparing the people who live in the kind of Salt Lake City area to people who live in more rural parts of the state. What we found is that the people who live in the Salt Lake area, they tend to have better survivorship after their cancer diagnosis than the people who live in more rural areas. But, and this is an example of what I was talking about when we talk about improving the quality of research and really taking it to the next step. For all those people who lived in rural areas, we looked to see whether they had any family who lived in the Salt Lake area. And if they did, their survivorship was great. It was just like the people who live in Salt Lake. So what this really showed us is that it's patients who live in rural areas who don't really have a support network around Salt Lake where they are going to have to go for their cancer care. Those are the patients who are most at risk after they get diagnosed with cancer. And that is incredibly valuable for physicians when these patients are coming in, because these physicians can counsel them and can ask, do you have a support network here in Salt Lake? Do you have people you can stay with? And if not, the physician can help direct that patient to resources that can help improve their survivorship. So for a couple of years, I was living in a wetland in Turkey where we would string up these big nets that caught birds migrating through the area. We would take them out of the nets, we would measure them, record what species they were, other information about them. And then for some of them, we'd put a little tracker on them so we could see where they went and then let them go and hope that we would catch them again a year later so we could get our tracker back. And with that information, we're able to say where these birds were going and what areas are important for conservation to make sure these bird populations are stable. Successful conservation requires international collaboration, not just international collaboration from politicians, but from scientists, so we can understand where these birds are going, what areas are important, and we can really direct our efforts to protecting them. I love birding, and I'm a big nature lover. It's why I was a conservation biologist before. And there's something really, really wonderful about just going out into a natural setting. It's an incredibly mindful activity because you're really focused in, you're watching. And this is one of the things I really love about birding is I can go out into the mountains here and see a yellow warbler in this summer. And next winter, that bird will be down in Panama. And the summer after, I could see it again. I mean, these birds are traveling across borders, across oceans and mountains and deserts. And it's just amazing to go out and see the diversity that's around us and to be so just connected and in tune with the natural world. A big part of my conservation research was in using lists people write down when they go birding or bird watching. Believe it or not, there is a website, it's called eBird, and it has billions of records of what birds people have seen where all across the globe. It's the most successful community science program of all time. What I was able to do during my PhD was use those data of where just casual bird watchers, these aren't scientists, they're just people like me who like birding, where they've recorded that they've seen. And by taking those data and comparing them across years and doing some other sort of big data biostatistics, I was able to see which species are increasing in population, which are decreasing, and which are sort of staying the same. That is what triggered this in my mind, where it's like, I bet I could do the same thing using healthcare data. My name is JJ Horns. I'm a big data scientist, and beyond the badge, I love birding.